Okay, let's take a look at question 6 in topic set 5. This question gives us some information about a gas, and then it says we're adding some more gas to that same container, and then the temperature goes up to 50 degrees Celsius, and pressure also goes up. The question is how many moles of gas were added. Okay, so let's kind of draw this out a little bit. So we have a container that originally have some gas in it, and the amount of gas is 1.5 moles. Temperature was 25, and pressure is 400. And what we did is we let some more gas in here. The amount of gas has increased, and so we don't know by how much. So the number of moles in the second condition is unknown, but the pressure now in the second condition is 800 torr, and the temperature in the second condition is 50 degrees Celsius. Okay, so you can write these ones as the first condition, T1 and N1. All right, now you can see that once we write it down in terms of those ideal gas variables, it becomes clear that we need to use one of those ideal gas laws variations. So we can start with just the PV equals nRT, which can be written as PV over NT equals R. And I like to write it this way because then what that means is that P times V over N times T is equal to a constant always, which means you can write it in two different conditions. So equals to P2, V2, N2, T2. And they tell you a constant volume container, so that means volume doesn't change in the two conditions. So V1 and V2 is the same, so we can cancel that out from the expression. So to figure out the number of moles of gas that's added, that means we need to take the difference of what we have at the end, N2, minus what we have at the beginning, which requires us to calculate N2 here using this relationship. So let's rearrange that expression. Okay, just to do a cross multiplication. So your N2 would be on this side, and then you just bring everything else to the other side. So the P2 and the T2 would remain there, and then the N1 T1 becomes the numerator because you do the cross here, and then the P1 becomes the denominator. And then it's just a matter of plugging in the values that you have. P2 is 800 torr. Now notice I don't need to change this to ATM because I have a P1 here at the bottom in the denominator that's also going to be in units of torr, so I can cancel that out. N1 is 1.5 moles. Now temperature though has to be done in Kelvin because that's how the gas relationships are observed. It's only in units of Kelvin. So the T1 is 25 degrees, so it has to be 25 plus 273 Kelvin, and then T2 50 plus 273 Kelvin, and then pressure 1 is 400 torr. Okay? And you can see that the units torrs and kelvins cancel, so you're left with number of moles as the final unit, and the answer ends up being 2.7678 moles. Now remember, that's N2, so the number of gas added is going to be N2 minus N1. So we're going to take 2.7678 moles minus 1.5, and that gives us 1.2678 moles, or if we round it, it'll be 1.27 moles.